Last time, we shrank a model until it fit in your pocket. TensorFlow Lite quantization, 3 megabytes running on a phone. That was the deploy stage at full depth. But here's the thing, every stage of this course, we deepened one at a time. Today is the capstone. We're going to take a single project and walk all 8 stops of the pipeline. Collect, pre-process, build, train, evaluate, save, deploy, predict. Back to back at depth in one script. This is the whole spine lit up at once. Remember the spine? It never changed. Every episode lived on one of these 8 stops. Embeddings lived in pre-process, attention lived in build, fine-tuning lived in train. We zoomed into each one. Now we zoom out and run the full lab. Same 8 stops, one continuous breath. The capstone lab, think of it as a relay. Each stage we trained separately is now a runner, and they hand the baton down the line. Raw text in at the start, a confident prediction out at the end. No stage skipped, no shortcut, the honest complete loop. Stop 1 and 2, collect and pre-process. We're doing sentiment on movie reviews, positive or negative. But we don't load a CSV into memory and pray. We build a real tf.data pipeline, read from disk in batches of 32, cache so the second epoch is fast, prefetch so the GPU never waits on the CPU. This is the difference between a toy and a project. Stop 3, build. And here's the lesson the whole NLP block earned us. You don't build a transformer from scratch for a real task, you stand on one. We pull a pre-trained foundation model, a Distilberto style encoder that already learned language from billions of words, and we put a tiny classification head on top. Then we freeze the encoder, its weights are locked, and train only the head. Reuse the giant, train the small part. Stops 4 and 5, train and evaluate. The honest loop. The backbone is frozen, so we're only fitting that small head. Fast, and it can't overfit the giant. We compile, we fit with callbacks. Early stopping watches the validation loss and quits when it stops improving. Model checkpoint saves the best weights, so a bad final epoch can't ruin you. Then we evaluate not just one accuracy number, a full confusion matrix. How many positives did we call negative? That's the truth the headline number hides. Stops 6 and 7, save and deploy, 2 artifacts, 2 destinations. Model.export writes a saved model. The format TensorFlow serving loads on a server. Then the TF-Lite converter squeezes the same model into a single flat file ready for a phone. One catch worth saying out loud, our model tokenizes raw text inside itself. So the converter has to carry those text stops along. We tell it to. One model, 2 homes, the cloud and the edge. Stop 8, predict the payoff. We take one fresh review the model has never seen, hand the raw sentence straight to the on-device interpreter, text stops and all, and watch it walk the entire spine to a single answer. Positive, 97% confident. Every stage we built is alive in that one number. And here's the map you now hold. 10 areas, vision, NLP, time series, recommendation, reinforcement, generative, edge, production, the math underneath. 8 stops on the spine, one repeatable loop you can run on any problem. That's not a course you finished. That's a skill you own. Go ship something real. Let's read it. One script, 28 capstone.py, 4 pages. Page 1 builds the data pipeline, loads the pre-trained model and freezes the backbone. Page 2 trains and evaluates with the confusion matrix. Page 3 saves the saved model and converts to TF-Lite. Page 4 runs the final prediction on a fresh sentence. Watch the gold box walk the whole spine. Imports and config up top, TensorFlow, Keras, Keras hub for the pre-trained backbone, and TensorFlow text. We'll need it both for the conversion and to run the model on device. NumPy and matplotlib for the figure. We set the constants once, sequence length, batch size, epochs, the model name. Collect and pre-process. We load the IMDb reviews with text dataset from directory, batching 32 at a time, and carving a 20% validation split right here. subsets of both handlers train and val in one call. Then the two pipeline verbs, cache keeps the decoded data in memory after epoch 1, prefetch with autotune overlaps loading with training, print the milestone, data batched, stage 1 and 2 done. Build then freeze, we grab a distill BERT classifier from Keras hub, preset weights, two output classes, logits out. The preprocessor that tokenizes raw strings is bundled in, so the model eats plain text. Then the key line, classifier.backbone.trainable, false. The giant is locked. Only the classification head will learn. We fine tune the last mile. Compile and train, the honest loop. Compile with the Adam optimizer, sparse categorical cross entropy reading. From logits, accuracy as the metric. Two callbacks, early stopping with patience 2 on validation loss, restoring the best weights, model checkpoint saving the best model to disk. Then fit, watch the logs. Val accuracy climbs to 0.94 and early stopping pulls the plug before we waste epochs. Evaluate. We pull the true labels out of the validation set, run model, predict for the logits, take the argmax for predicted labels, and build a confusion matrix with tf.math confusion matrix. Then we render it a white 2x2 grid, true versus predicted. This is where you see which mistakes the model makes, not just how many. Save and deploy. Model.export writes the saved model directory. That's your TF serving artifact. Then the TF light converter pointed at the saved model. Because the graph carries text tokenization ops, we widen the allowed ops set, built-ins plus select TF, and allow custom ops so those text kernels survive the conversion. Call convert, write the bytes, print the size, the same brain, server ready and phone ready. Predict, the final stop. Here's the part people miss. A plain interpreter can't run those text ops, so we load with interpreter with custom ops and register the tf.text kernels. We grab the serving signature, hand it one fresh raw review. An absolute triumph, I was moved to tears. Read the logits, softmax them, and print the verdict. Positive 0.97. One fresh sentence, no manual tokenizing, walked all 8 stops to an answer. The loop is closed. And that's the whole pipeline, end to end in one breath. 8 stops, 10 areas, one script that ties the spine together. You started this course not knowing what a tensor was. You're ending it, able to collect data, fine-tune a transformer, evaluate it honestly, and ship it to a phone. There's no next episode, this is the finale. But there is a next project and it's yours. Go build it, go ship something real. Thanks for taking the whole lap with me.